if you guys are going to be there completely ready before we can start up a session, how can I wait? So this is where I started the session now 3 minutes earlier, and this is all because of your presence. Hi to all the students, how are you all doing? I have so many students over here making the chat colorful, amazing. So we have Khushi, we have Lakshmi, we have Abhi, we have Sarita, and yes, a lot of you would be joining up. So let's start the session where we are going to be diving into a lot of questions where you will be able to solve these and you will gain more confidence. So if you even, there would be a lot of questions where you might not be able to solve, but do not worry, I am holding up your finger. I'll be taking through, making you go through all the solutions, all the tricks, all the necessary information that you should require to solve the question. And even, as atomic structure is a chapter from physical chemistry, it's very easy to read and interpret the questions. You should always read these questions as riddles. And from today, I would say, on this particular channel, this is the first time I'm bringing up a problem solving session for you guys. So ultimately this session will happen, these type of sessions will happen all the time as soon as we'll complete one chapter. I am going to be bringing up for solid state as well, but right now guys, pay attention. What are we looking at? We are looking at previous year questions. So even if you see a previous year question, do not worry, oh, it's a previous year question, I cannot solve it, or maybe it is going to be tough. No, that's not gonna happen. Okay, we will be going through all the questions and we will solve all the questions till the end. Okay, so how many of you are going to be there till the end? First of all, let me know in the chat. And hi to the genius Yuva, and a very very happy Teachers Day to all of you guys. And why is that? Because you guys show us punctuality, you guys show us discipline, and dedication, and a lot of things that we learn from you guys as well. And this is where even you guys are my teachers. So happy Teachers Day to not only just to me, it should be for you as well. Thank you so much for always being in the chat, always encouraging me in the sessions, outside the sessions as well. Chalo. So now in today's class we will be diving into the questions. For those who haven't followed my Telegram channel, do follow it. The link is going to be there in the description. Apart from that, there is one more Telegram channel that you should be joining up. The link is going to be there in the description. All the links are going to be there in the description. And you should also follow me on Unacademy as well, @Luv Mehan. You can just search my name, or you can just type @LUVMEHAN and you'll get my profile. Okay. And apart from this, guys, you should remember that ultimately for JEE Advance, there is a crash course from my end where students can actually refer, and students who are actually the 2023 and the 2022 students, there are English batches which have started for you. See, I'll tell you something. The frequency of English batches are slightly less than the frequency of Hindi batches. Okay, the number of English batches are less, and it has started. These batches have started on 18th and 11th of August. Do not miss these sessions out. Okay, if you are willing to join an academy, do it as soon as possible, and you just have to use the code LOVEGURU. Okay, so do remember that. And over here you should remember 2022 and droppers, you have a lot of batches. 2023 students also have batches, so which has started on 1st September. But I would also recommend you to go for the Shine and the Spark batch, where everything is covered in English. Okay. Yes, and apart from this, the code that you guys have to really use to unlock all the benefits on Unacademy platform, which is LOVEGURU. Okay, so do remember this code LUVGURU. It's one word, so do not put spaces. And apart from this, your enrollment is going to be free. But for what? The scholarship test, Unacademy's biggest scholarship test, that is Unacademy Combat. And over here, the scholarship worth ₹4 crore, which is the pool prize, is available. For the rank 1, 2 and 3 holders, you'll get 100% scholarship. For 4 to 10, 75%, and so on. You have 25 and 50% scholarship as well. And you should definitely learn on Unacademy with scholarship. So do not forget to give this combat. It happens every Sunday 11 AM. Today was Sunday. How many of you are giving it regularly? Let me know in the chat. Okay, and apart from this, you should remember that India's best educators are available on Unacademy Plus and Iconic subscriptions, and you get their live classes where you can actually ask your doubts in no time. Okay, so in real time you can ask your doubts in live classes. The teachers PDS and notes are available. The courses are structured, so you exactly know when these courses are going to end. Apart from this, live test and quizzes happens on Unacademy, which gives you a lot of competitive feeling. Apart from this, in Iconic you should remember personal coach, study planner, study material. If you need study material and if you do not want to buy any of the books, you can still go for Iconic. So do remember that. If you take plus, then also you can upgrade on Iconic later. So do remember that. I am going to recommend you guys for droppers and freshers for 2022. I am recommending you 12 months, where 12 months cost, the whole 12-month cost comes out to be 34,650 after discount. Okay, after using my code you'll get a discount of 10%, and that is the price you'll get. And for 2023 students, I recommend you 24 months of subscription, where the actual price comes out to be for 2 months or 2 years, it's 50,400. You will never see subscriptions as cheap as this one. Even if you would compare with your any of the local coaching centers, 2 years of coaching fees is going to be more than 1 or 1.5 lakhs, right? So do remember, these are the cheapest subscriptions for you, and you have the best teachers available. So do not forget to use the code LOVEGURU. And this is where we are jumping into the session. How many of you are ready? So you will be able to see the options, but let's not see the options and simply guess it. We should solve it, and we will see how to read the question, because giving an answer is fine and you should be correct, but if you do not know how to read a question, and if the question changes its language, then it can be tough. So ultimately, let's learn how to read a question, and let's go over here. The question talks about the quantum number of 4 electrons are given below. Okay, electron 1, electron 2, electron 3 and electron 4. The correct order of their increasing energies. Whenever we talk about energies, Bohr's rule should come in your mind, and whenever we talk about the Bohr's principle, ultimately you should remember N plus L rule should be taken care of. Now we will only look for the N and L values. N for Nagpur, L for London. Okay, we will not talk about M. Okay, and we will not talk about MS as well. So now guys, pay attention. Over here, whenever we look for the less N values first, L value 1, L value 2. So which one is going to have lower energy? It's going to be the fourth one, which is going to have the lower energy, correct? And now when we talk about this, becomes 5 and this also becomes 5, which is going to have less, slightly lesser energy, second compared to third. And then N 4 plus 1, and this is 4 plus 2. This is 6, this is 5. This is how it is going to be. 4, 2, 3, 1. Which one is the correct answer? And the correct answer to this question is 4, 2, 3, 1. C is the correct answer. N plus L values. Okay, and when the N plus L becomes same, where did we see that? Here. So lower the N value, lesser is going to be the energy. Okay, so do remember that. And now we are moving ahead. We are going to move ahead. And over here, the question talks about if P is the momentum of the fastest electron ejected from a metal surface. Pay attention. There is a metal surface. This could be photosensitive surface. Radiation came over here, and electron got ejected. It's very fast. Do remember that. Okay, electron is ejected. After the irradiation of light having wavelength lambda. So this was having lambda. Okay, then for 1.5 p momentum, right now this was lambda 1 and this is p, having momentum p. Then they're talking about when the momentum becomes 50% more, the wavelength of the light should be. So we're talking about what should be the wavelength. Also, they have given you a very big hint. And what is that? Guys, you should solve it as well. Hi to Pratham and everybody who's just spamming up. Amazing. You do not worry about the options. If you are going to do that, I am probably going to remove the options from the next time. Let's do how to do this one. Okay, let's see. They're saying assume the kinetic energy of the ejected electron be very high when compared to the work function. So what are they saying? Pay attention. The first assumption that they're asking us to consider is that the work function has to be neglected over kinetic energy. And now what was the photoelectric effect mathematical representation? It was the energy hc by lambda is equals to the work function plus kinetic energy. But we are going to take it as 0. We are going to neglect this. So remove it. So we are simply comparing the energy of the radiation and the kinetic energy. But you should remember one more thing. Let's write it. Let's write it down. When we are writing, it's hc by lambda, which is equals to half mv square. Now guys, pay attention. Now we are multiplying and dividing m. Multiplied by m, divided by m. Now what is going to happen? This m and this m becomes half m square v square upon m. Correct? mv whole square. This is mv whole square. What is mv? Mass into velocity becomes momentum. Mass into velocity becomes momentum. Correct? And now over here it is going to be momentum square upon 2m. And what are we having over here? hc by lambda. Take everything on one side. Take everything. So I am just keeping up lambda over here. I'll keep lambda here. Okay? And I'm gonna keep everything on the LHS. So it is hc into 2m square upon p square. Clear? Till here, is it clear? Now we have to look for the relationship. Over here from this, we can clearly write lambda is inversely proportional to momentum square. We can write this, correct? Now we have two lambdas. Lambda 1, where we got momentum as p, and lambda 2, where we got momentum as 1.5p. Correct? Now we'll just take the ratios. It will become easier. And now over here, what is going to happen? Lambda 1, or let's keep lambda 2 in the numerator upon lambda 1 is equals to, now for this one, what is going to be the scenario? It is inversely proportional, right? So in case of lambda 2, it is going to be inversely proportional to the momentum, and on the top, something like this. Clear? Yes? And now pay attention. Over here, this is 3.2. So I'm going to write it as 3 by 2. I mean, because it is in the denominator, right? That's the reason. Square p square upon p square. Cancel it up. Your answer comes out to be 4 upon 9. Lambda 2 is equals to 4 upon 9 lambda 1. Clear? Yes or no? Yes or no, boys and girls? How many of you actually were able to solve this? I'm not talking about, see, there would be some dropper students, there would be some students who have really seen these questions. Previous questions, a lot of students do it. I don't care. If you are giving me an answer as soon as you see the question, the moment they will change the question, you will get negative marking. Okay? Over here, sir, मुझको 68.9 पे NIT मिलने के chances हैं या drop? 96.8 पे you will get the NITs. Do not worry about it. Even I have made a video on this. That's the reason I made that short video. Do check it out. It was uploaded 2 days ago. I have made at which particular percentile you can get which particular type of NITs. Go check it out. Okay? So don't worry. Now, I did solve. Amazing. How many of you did solve? Like Khushi, let me know in the chat. Give me a smiley. If you are able to solve it correctly as well, give me double smileys. Okay? And now let's move ahead. Over here, the correct answer to this question is A. I don't want any damn student giving me just the, the answer as soon as they look into the question, because there's no point. You simply coming and wasting your time. Do not do that. Please don't do that. Okay. So now, which one of the following about an electron occupying 1s orbital? So hydrogen, they're talking about one proton system. Okay. And around this there is first shell and second shell and so on, right? When we talk about the electron at 1s, we're talking about electron at the first shell as well. Atom is incorrect. We're talking about incorrect. The Bohr radius is represented as A0. What is the value of A0? Just giving you some extra information for revision. It is 52.9 picometers. or 0.529 Armstrong. But now the point over here is, which of these statements are incorrect? You know what? So now let's read them one by one. The electron can be found at a distance of 2a0 from the nucleus, which is absolutely correct. And why is that? Because you should remember, we cannot define the correct position. We cannot clearly say, oh, the electron is present over here only. Whenever we talk about the wave function, what we really see is that the electron, if this is a0 and this is 2a0, electron is still present over there. So don't worry about it. The magnitude of the potential energy is double than its kinetic energy of an on an average. Yes, it is always true. Now, the probability density of the finding an electron is maximum at nucleus, where we are going to talk about it. And the last statement talks about the total energy of the electron is maximum when it's at a distance a0 from the nucleus. Guys, now pay attention. What I have really told you. Achha, by the way, if you really like the question, hit the like button. Guys, why is this electron staying over here? Why is it not going here or any other shell? Stability. If electron feels maximum stability over here, can I say it is going to have minimum energy over here? Minimum energy over here. What does the fourth statement talks about? It says the total energy of the electron is maximum. And that's wrong, right? It's a wrong one. It should have minimum energy, correct? That's the only reason it is actually staying at that position. And D is going to be the correct one. Do remember that, okay? So yeah, and ultimately whenever we talk about the probability density, from the nucleus, near to the nucleus it's high, and as we go away it decreases for the 1s electron, okay? So that's what you should remember. Near to the nucleus, it's not exactly nucleus, near to the nucleus it's higher, and as we move away from it, it decreases. So do remember that. Yes. So this one on the right hand side we have, over here what are we really having? The radial distribution, radial probability function graph, okay? So do remember that. Now moving on to the next one. The electrons are more likely to be found. Over here, what are you really looking at? The wave function is what you are really looking at. So you should remember, when a wave function, what is this particular thing telling us? It is telling us the probability of having an electron in that particular region or not. And now over here, what do you guys really think? So if wave function value becomes 0, that means probability of finding electron is also 0. So we are talking about is the electrons are more likely to be found at, I'll tell you. So do you see this region? Is this 0? No. Is this shaded region 0? No, right? What about this one? No. So at region A and at region C, we will find electron. But now I'm asking you one more question. At which particular region you will have a node? Guys, you'll have a node. Let me know. So region A and C is going to be the correct one. But where is the node? And node is going to be wherever the curve touches the origin, or maybe the axis. So it's here. Wherever the curve touches x-axis, that's going to be the where you'll find a node. So is this really clear? This is a node, boys and girls. This is a node. So do remember this. Okay, and now let's talk about more. Over here, whenever we're talking about the ground state energy of hydrogen atom, next question. Ground state means N value is 1. Hydrogen atom means Z value 1, which is given to you as minus 13.6 eV. What is the formula of En? En comes out to be, do write it down. It will help you, and it's only for you, not for me. Okay? So minus 13.6 eV into Z square upon N square. That's the formula. Where Z is the atomic number, N is the number of orbital or the number of shell. The energy of second excited electron of helium plus is going to be amazing. Use the same formula. So we're talking about the second excited state. N is equals to Is it the first excited state or the second excited state? It's the second excited state. Whenever we talk about the first excited state, it is going to be n is equals to 2. And whenever we talk about the second, it could be n is equals to 3. Do you think so? What do you think? I'll show you. The correct answer to this question is absolutely C. And how to do this one? So whenever we talk about the second excited state, it is going to be n is equals to 3. How? See, if this is the ground state, n is equals to 1. We're talking about first excited state, it is going to be n is equals to 2. But the question is talking about the third excited state. Second excited state. So while getting second time excited, it becomes n is equals to 3. So this is what you really have to use. And how is it going to be? Just simply direct, formula application. Z value is going to be 2 square upon 3 square. That's it. 4 upon 9. Minus 13.6 into 4 upon 9, and that's going to be your answer, and that's going to be 6.04. But the unit, what is going to be unit, guys? What is going to be the unit? It's an EV. Now I'm going to ask you one more question, because if you think that these are the only questions that I am going to ask you, you're wrong. Convert EV into joules. What will you write? Let me know. Let's see. Because you guys are really great at looking at the previous questions and giving me answers. Now let me know, whenever we have to convert 1 EV into joules, how many joules is this going to be? Let's see, because anyhow such things are going to be helpful. Hi Ranjit, yes, you are a bit late, but no issues. Now guys, let me know, what are you looking at? Come on. Thank you so much, Abhi. Nobody? Yes, 1.6 into 10 raised per minus 19. 1.6 into 10 raised per minus 19. Amazing. Genius, Yuva and Khushi. 1.6 into 10 raised per minus 19 joules. Do remember this. Every JEE or NEET student should remember this conversion. Do remember this, okay? Yes, I'm so glad that everybody is giving me the correct answer. Amazing. And now let's move ahead, because they can ask you the value in joules as well, yaar. That's the only reason I'm talking about. So a stream of electrons, a lot of electrons that they're talking about, from a heated filament was passed between two charge plates. So there is charge 2 charge plates kept at a potential difference of V, electrostatic units, voltage. Okay? So across these two plates there is a potential difference which is V. If the potential difference is V, what is going to be the energy of the electrons? It's nothing. It's very simple. It's EV. The charge of the electron into voltage. This is the energy for one electron. Okay? Do remember that. If E and M are the charge and the mass, you guys have to really tell me what is the charge, what is the value of E and what is the value of M in the chat. And the mass of the electron respectively, then the value of h by lambda, where lambda is the wavelength associated with the electron, is given by. Amazing question. So anyhow, it's very easy. Whenever we talk about the wavelength, or whenever we're talking about the h by lambda scenario, how is it going to be? You should just simply remember, whenever we're talking about EV, that is the energy, what we are talking about over here is hc by lambda. Just simply equate both of these, because it's energy, right? So over here we are going to talk about the hc by lambda. And now what are we really looking at? We should also know about the mass as well. So is this going to be correct? By the way, we'll talk about this. A charge 1.6 into 10 to the minus 19. Amazing. Yes. And what's next? What about the mass? What about the mass? Let me know. So guys, whenever we are actually having an electron which is in motion, the kinetic energy is going to be this much. This is how we are going to write the kinetic energy, correct? And which is actually going to be equals to the hc by lambda as well. So do remember, we are going to do it. The correct answer to this question, and everybody is giving me C, so I have to show you. Now over here, pay attention. So whenever we're talking about the lambda, according to the de Broglie's equation, it is momentum is equals to h by lambda, correct? And now guys, pay attention. Whenever we talk about the kinetic energy, We also saw this in the first question. Kinetic energy of a particular electron is actually shown as the p square, the momentum square, upon 2m. Correct? What are we going to write about the kinetic energy over here? Pay attention. Ultimately, what we are writing is P is equals to 2m kinetic energy whole under root. That's what we are going to write. And I have already taught this to you whenever we were doing atomic structure as a chapter. And now over here, do remember one thing. Whenever we're talking about the kinetic energy, you know, the electron was in motion all because of the voltage and because of its charge. This energy is nothing but and that's going to be your answer. So when we are talking now put P as this much. It is 2m eV whole under root. H by lambda comes out to be 2m eV whole under root. You know what? This is a derivation. This is a derivation, and derivation came as a question when we were talking about 2016 attempt. So do remember this, okay? Even the theory, even the derivation part can be a question. So that's the reason you should go through derivations very, carefully. And now let's move ahead towards the next question. Which of the following is the energy of a possible excited state of hydrogen? Possible excited state means first excited state. First excited state is going to be from n is equals to 1 to till n is equals to 2. This is the first excited state. So the n value that you have to talk about is 2. The formula En again minus 13.6 z square upon n square eV. And now we are only going to talk about 2. Minus 13.6 into 1 square upon 2 square. Answer comes out to be minus 3.4 eV. That's going to be a correct answer. And this question, which is there in 2015, had been repeated in a lot of other previous years as well. This questions had been there in the a lot of attempts so many times. So this is a very generic question, but it is going to be there, and for NEET students as well, it will be there. Do remember that, okay? And now, by the way, why do I really have to remind you guys to mark the attendance? Hit the like button, boys and girls. And now let's move ahead. Over here, what are we really talking about? The next question is about the correct set of 4 quantum numbers when the valence electrons of rubidium is given to you as 37. Guys, if you do not know how to write the electronic configuration, take the help of noble gases. Guys, write it down with me. Helium, then we have neon, then we have argon, then we have krypton, then we have xenon, and then we have radon. Correct? Let's write the atomic number values. Over here, Z value 2, then we have 10, 18, 36, and then we have 54, and then ultimately we can write, because how are we doing it? 8, 8, 18, and then again 18, and then we are going to go for 32. So add 32 and 54, you'll get, for the radon it is going to be 686. Okay, and now what atomic number has the question given you? It's 37, which is just bigger than krypton. So how are we going to write about rubidium? Rb is equals to krypton. Then which particular shell are we talking about? Pay attention. First shell, second shell, third shell, fourth shell. After fourth shell, after the fourth period, there's going to be a fifth one, right? So this is going to be 5s, just 1 electron extra. 1. Now we have to look for the quantum numbers for 5s1. And now guys, pay attention. Is this a quiz? You can take it as a quiz, but we are actually doing it as problem solving. And now, yes, the correct answer to this question is A. I am not giving you, names this time on the chat. And why is that? Because those days are gone. You guys have, now grown up. You guys really know now you should be more focused on solving rather than just diving into A, B, C, D is the answer. Don't do that. Okay. Now, ultimately, it is going to be N value, which is 5. It shows over here. For the S value, L value has to be 0. And then ML value for L value 0. Guys, what if I write ms value minus half? Will it be correct or will it be wrong? If I write ms value minus half, let me know. If there would have been an option minus half, will it be a wrong thing? Come on, let me know. I don't think so. Do remember that, okay? Even if they're giving you ms as minus half, it's not going to be wrong. Okay, so do remember that. Now, as the question is giving you plus, yes, A is the correct answer. And now let's move ahead towards the next one. The question talks about the electrons identified by the quantum numbers n and l. So now you guys have to let me know how to do this one. So can be placed in the order of increasing energy. Again, which rule? Of Bohr's principle. N plus L rule is what you guys are going to use. So look for the n value smaller first. N value smaller and L value also smaller. This is fourth. This is going to have least amount of energy, right? 4. Then what are we really having over here? What about this one? Same, right? It is 4, n plus L value 4. Then we are going to write the second one. And then n value 5, n plus L value 5 and n plus L value 5. As 3 is there compared to 4, this is going to have lesser energy. 4, 2, 3, 1, that is going to be correct answer. 4, 2, 3, 1. Is this clear? Hi Stella, welcome to the session. Do hit the like button and share the session amongst your friends. Okay. And now moving on to the next one. A gas absorbs this particular questions. Has to, we just have to take care of the conservation of energy. So do remember that. And now this question talks about a gas absorbs photon of 355 nm and emits 2 wavelengths. What is going to happen when an electron is going to actually, a gas is going to absorb a photon? Whenever energy will be absorbed, the energy level will increase. Correct? This is E, let's say 0, and this is E1. Okay, and then emits 2 wavelengths. It first of all came over here. So this is E1, I should write. This is E2 till here, and then it emits the another wavelength, which is E3. Correct? If one of the emitted wavelength is 680 nm, so this one is, let's say we write it as lambda 1, 355 nm, and this one is going to be lambda 2. We have to calculate the lambda 3. And how are we going to do that? Pay attention. So ultimately we have to write E1 is equals to E2 plus E3. Write the formulas. Hc by lambda 1 is equals to Hc by lambda 2 is equal plus Hc by lambda 3, and this is what we have to calculate. These two are given. Guys, cancel Hc. It's common on both the sides. What you guys are getting is lambda 1 is equals to 1 upon lambda 2 plus 1 upon lambda 3. I'll tell you one more hint. Guys, pay attention that you should always remember whenever we're talking about this much energy was absorbed, right? I see this 355 as UV. Okay, and it is actually producing visible. Correct? You should remember, as it has absorbed a UV wavelength of 355 nm, it will never emit a stronger energy. It cannot emit a stronger energy, and stronger energy over here is what I can see is 325 nm. 325, wavelength of 325 nm is going to be much more energetic. From where is this extra energy going to come? So do remember that. Okay, so specifically B is not going to be the answer. You can always eliminate some options. And now over here just add it. 355, guys, solve it. Minus 1 upon 680 is equals to lambda 3. 1 upon lambda 3. Yes? Clear? How many of you are giving me the correct answers? Come on now, it's your time. Now you guys have to solve it. Thank you so much, Stella. S. Come on, boys and girls, let me know. It's your time now. I'm not going to do that. I mean, I can simply just give you some extra steps. Come on. C? Yes, the genius UY is absolutely correct. The correct answer to this question is C. Amazing. Okay, so do remember that. Now ultimately this is how we have to do. Okay, this is the energy where 355 Nm was absorbed, and this is 680. Which is more energetic? This one is more energetic. When some part is less energetic, obviously the another part is also going to be less energetic than 355. That means the value has to be always greater than 355. So do remember that. And now moving on to the next question. Over here the question talks about the frequency of light emitted from the transition of n is equals to 4 till n is equals to 2. This is what the question is talking about, but for which one? For helium plus. Helium plus has a Z value which is 2. So do remember that. Is equal to the transition of hydrogen atom corresponding to which of the following? So guys, now they're talking about if we have n is equals to y and n is equals to x. We don't know, but the electron should come for hydrogen where Z value is 1. What should be the value of x and y? Where the energy gap is going to be same. And how do we get to know that they're talking about the energy gap? Because they're talking about the frequency should be same. When frequency will be same, energy delta E should be same. Because anyhow, you should remember delta E is equals to h nu. When this is constant and this is constant, obviously this is also going to be constant. And now let's see how to do this one. Yes, energy gap for both. Now I'll tell you something. If you would look into this particular type of question anywhere, you will actually see a lot of big solutions. I'll give you a trick. Are you ready for the trick, boys and girls? Just write the formula with me. Just write the Rydberg's equation with me. Now delta E is equals to minus the Rydberg's constant 2.18 into 10 is for minus 18, and then write Z square 1 upon NF square minus 1 upon NI square. Now it's a very amazing one. Pay attention. What are the numbers given to you guys? It's 4 and 2, right? I'll write it over here. So from transition is from 4 to 2, right? So this is going to be over here, which is going to be 2 square, and over here it is 4 square. Correct? Can we write this? Clear. Now pay attention. What is this value? 2. Square of it, it's 4. 4. Now put this 4 inside. So we are going to put 4 inside. Okay? 4 upon 4 minus 4 upon 16. Z is gone. Now what's next? Can I multiply this with the 1 square in the front? I mean on the numerator, can I do that? I can multiply n number of times the 1 value, right? So I'm doing that. This 1 over here is the atomic number of hydrogen. Okay? Divide it. This comes out to be 1. Can I write it as 1 square? This comes out to be 4. Can I write it as this comes out to be 2 square? So for the hydrogen atom to show hydrogen electron showing this transition having same delta E value, it should be from 2 to 1. And what is going to be the correct answer? From n value 2 to 1. You do not have to calculate the frequency first and then calculate the Ni and Nf values. No, simply putting it inside, putting these this Z square value inside and simply calculating the answer. How is it? Let me know, because it actually saves a lot of time. If you would see the solution, those are one big page solutions for this particular type of questions. Amazing, right? See, this is how the solution is. Which one is better? Would you go for this one or would you go for the one which I have shown it to you? Which one? Who wins? The solution or Love sir? Let me know. Okay? यार इस बात पे तो OP बनता है ना. For the trick, I think you can actually write trick OP in the chat. ठीक है, चलो, amazing. Now let's talk about more questions, and I'll be giving you awesome tricks for different questions. So stay tuned. The vapor of, and by the way, we are trying to solve each and every type of question which from the chapter atomic structure, all the concepts. Amazing, chalo. And now the vapor of Hg absorbs some electrons accelerated by the potential difference. Again, electrons accelerated by potential difference of 4.5 volts. Chalo, voltage is given to you. I was thinking they're going to give us V. This is voltage. From the rest, as a result of a single incident electron is supposed to be converted into light emitted by the electron in a single Hg atom. We're talking about mercury atom. Find the wave number 1 by lambda of the light. We're talking about 1 by lambda over here. And what is given to you? The 4.5 volt. So do remember, what is going to be the energy, boys and girls? For one electron accelerated because of the voltage, the energy that you guys are going to write is going to be EV. 1 EV. But no, I don't want 1 EV over here. How much is the energy in joules is what you have to give me. Write it down. The joules is going to be 1.6 into 10 raised power minus 19 joules. This much is 1 EV. This is the energy of the electron. And if this electron has to provide or has to provide its energy in the form of radiation, then ultimately you should just remember Hc by lambda is equals to 1.6 into 10 raised power minus 19. But this is for 1 EV. What if I do ask it for 4.5 EV? Then you will simply multiply 4.5, right? Do it over here as well, okay? So I'm going to erase things over here. This much is the energy. But this much energy is in joules right now for you. And now pay attention. What is H? The Planck's constant. Keep 1 by lambda over here, which is nothing but the wave number. Now pay attention. 1.6 into 10 raised power minus 19 into 4.5. H value 6.626 into 10 raised power minus 34. Value of C 3 into 10 raised power 8 meters per second. Solve this one up and you have the value of the wave number. Are we trying to calculate the wave number? Yes. The question talked about the wave number. Do it. Yes, chemistry is chemistry. It is going to help you for NEET and any other examination as well, okay? NEET, JEE or any other competitive examination, because chemistry is chemistry. What is the major difference when we talk about in the NEET based chemistry? The questions are too much direct. They ask less calculations over there. They ask more conceptual questions over there. Even when we talk about the organic chemistry, the level of the question becomes easier. But if a student can solve JEE main chemistry, I'm not talking about advanced. Let's keep advanced aside. When a student can solve JEE mains chemistry, you will get 100% in JEE this NEET chemistry. Okay, so do remember that. Now, ultimately, sir, why are you not replying YT chats? No, it's not like that. Whenever I'm solving up or showing up a question, obviously I'm not going to do that. But as soon as I am giving you the time to solve it, then yes, I am going to see your messages. So don't worry, and do not retract your messages. Okay, and the correct answer to this question after solving this one, see, I am not going to solve you. I'm not going to solve any of these calculations because it's your time now. And what's the answer? Khushi is giving me A. The correct answer to this question is A. Khushi OP in the chat. Now, let's move ahead and talk about the next question. Pay attention, boys and girls. A radiation corresponding to transmit... A second. We have done this? No, it's not for the helium plus. It's the hydrogen. I thought the question got repeated. The radiation corresponding to transition from N is equals to 4 till N is equals to 2. So, guys, first and the foremost thing. Which series is this? Layman, Balmer, Paston, Brackett, P-Fund. You have to let me know. Which one of them is? Which one are we talking about? From N is equals to NE till N is equals to 2. It's the Balmer, right? and you will always look for a wavelength which is in the visible region. But anyhow, we'll talk about that later. Falls on a certain metal. Okay, so that radiation, whatever radiation is you guys are going to get, is going to have a wavelength. Now we have to use this energy that is striking up a metal, having a work function 2 naught eV, right? So now let's look for the delta E first. Let's look for the hc by lambda first. So how will you calculate this? Delta E from E4 till E2. So let's do this. E4 minus E2. What will you do? See, anyhow it should be final minus initial. So final minus initial. 2 should come first. And now what is going to be the formula? Minus 13.6. Z square is 1 upon 2 square minus 13.6 upon 4 square. Give me an answer over here. First of all, for delta E only, give me an answer. This is going to be minus 3.4, and this is going to be 16. 13.6 divided by 16, which is going to be smaller than 1, minus plus 0.86, if I'm not wrong. Let me know. Just confirm. What is going to be the answer over here, boys and girls? Let me know. 0.86 or 87, 85, something like that. Let me know. What is it? It's on you. You have to help me. Just like the Dora the Explorer. Have you seen Dora the Explorer? Can you see maps? Can you see the answer? Can you see the question? Something like that. Come on, let me know. Sir, you could see retracted messages also. Yes, I can see. So do not worry about it. 0.85. Shall we go for 0.85 and not 0.86? Chalo, theek hai, but anyhow, if it is 0.85 is what you're calculating, and I remember the value which is 0.86, it's good. Theek hai? Chalo. Now over here, let's pay attention. What is going to be the answer over here? It's going to be somewhere, if you keep 0.85 as well, minus 2.5455 roughly. ठीक है, minus 2.5455. That is going to be the case. Everybody on the same page? Yes? No sir, I'm Chota Bheem fan. Okay, Chota Bheem fan. Okay, ठीक है. I have actually seen a lot of Dora the Explorer with my younger brother when my age was gone, but he used to see it. But anyhow, it's fun. It's fun watching some silly cartoons. It's amazing. Time pass, yaar. I mean, when was the time when I used to see maximum amount of cartoons? It used to be my summer vacations. The summer vacations starts from May and still end of June. So that's where I saw a lot of cartoons when I was in school. Chalo. So now you ultimately have this much is the hc by lambda. Now pay attention. hc by lambda is equals to work function plus kinetic energy. What is the value over here? 2.55. What is the work function? 2 over here. What is going to be the kinetic energy? Just subtract 2.55 by 2. Comes out to be 0.55. And yeah, 0.55 is the correct answer. How to be energetic like me? Just first of all be happy, because you know what? Whenever I am coming in front of you, what do I really think of? I look for very cute, very chubby, or very cuties, which I might not be able to see right now, but are actually taking up the session. है ना? And whenever you're looking at me on maybe on your laptop or on your mobile phone, even I can say something which can make you feel happy. You can have some smiles. So that is the one thing that I keep in mind, and it keeps me going. So that's how I keep my energy high. है ना? Amazing. Chalo. 0.55 EV is going to be the correct answer. है ना? And now let's talk about the next question. Over here, which of the following curve is correct for a black body radiation? So what does a black body radiation do? Black body, first of all, is a substance which has the capability of absorbing all the radiation and also emitting all the radiation. Okay, so now you should remember, whenever temperature 1 is cooler than temperature 2, temperature 3 is hotter than temperature 2, and temperature 4 is hotter than temperature 3. Then what's the scenario? You should remember, whenever we increase temperature, the intensity increases, but the peak wavelength is actually getting much more lower and lower. So the peak wavelength is going to be much more energetic one. So if this is T1, the peak wavelength is, let's say, red. Then when you increase temperature, the peak wavelength became yellow. See, it's shifting towards the origin. Wavelength red, a wavelength of red is longer than wavelength yellow, and the wavelength is decreasing. But also, if you would see, these peaks, intensities are also changing. Intensity increases, wavelength decreases. Then we are talking about temperature 3, wavelength, and now the temperature 4. Maybe could be violet, blue, whatever. I'm just giving you an example. But intensity increases, and that's how a black body radiation works. Okay, do remember that. Now we are moving to the next one. Sir, I'm very afraid because I have stage fear. See, I'll tell you something. The moment you see, do I do mistakes in front of you guys? Always remember that. Do I make mistakes in front of you? Do I sometimes have a question, having a misprint? Yes. But are you here to judge me? No. Nobody is actually have time in this world to judge you. And if they actually have time, they're simply idle people. And you should not care about idle people. Okay? So one should never have a stage fear. If you do a mistake, say sorry. You did a mistake unintentionally, correct? No point of having stage fear. Okay? So do remember that. Now moving on to the next question. The radial nodes present in 3s and 2p orbitals are respectively. Radial nodes. Do you remember the formula for the radial nodes? Radial nodes have a formula n minus L minus 1. For 3s, 3 minus 0 minus 1, which is 2. For 2p, n minus L minus 1, 2 minus 1 minus 1, 0. 2 and 0 is the correct answer. B is the correct answer, not A. You're most welcome, Stella. Right? Kasinath SR is giving me the correct formula. The genius Yuva gave me the correct formula. Amazing. And now, let's move towards the next one. A photon of light of wavelength 6000 Armstrong. 6000 Armstrong has energy E. What will be the wavelength of a photon of light which has energy of photon 4 times the E? Guys, pay attention. E has a formula hc by lambda. Correct? Can I write E is inversely proportional to lambda because both of these are constants? Right? It is this way. Now I'm going to write two formulas. E1 is equals to 1 upon lambda 1 and E2 is equals to 1 upon lambda 2. I'm going to take ratios. So how I'm going to write? E1 upon E2 is equals to lambda 2 upon lambda 1. What is the value of lambda 1? 6000. And what is the relationship between E1 and E2? E1 is E and E2 is 4E. Correct? Cancel E and E. 4. Can I write this? 1 and 1500? Yes. So now pay attention. Ultimately, just bring 1500 on the LHS. 1500 Armstrong is the correct answer. Come on, boys and girls, hit the like button. And yes, when energy is 4 times, the wavelength is always going to be 1 by 4. It's inversely proportional. It was actually, the question was, the solution was over here itself. The question, if the energy has to increase 4 times, then obviously the lambda has to be decreased, right? So do remember that. The lambda has to decrease, like 4 is going to be here. It should be lambda by 4, right? Then only it will become 4e. Simple, simple. And now let's move towards the next one. Yahan pe we have a next question. Energy required to stop the ejection of electrons from copper plate. Copper over here is acting and behaving like a photosensitive surface. So the energy that we require is 0.24 eV. I mean, the point is, if this is the copper plate, radiation is coming up and electron of copper is ejected. To stop this electron come up, to stop this, how much energy are we applying? How much opposite voltage, stopping voltage? This is stopping voltage. Are we providing 0.24? That means this much is the kinetic energy of the electron. If let's say this is the kinetic, if X is the kinetic energy of a particular substance, and if you apply opposite energy, then only it will stop, right? If you're applying 0.24 eV of energy to stop electron, that means that is the kinetic energy of the electron. So do remember that. So that kinetic energy, I'm going to write, this is the kinetic energy of the electron as well. And now, if the radiation is 253.7 nm, nanometers, the work function is, now I'll give you one more trick. Guys, a lot of times you have written this. E is equals to hc by lambda. Do you know one thing? That whenever they give you the lambda value as nm, in nm, not Armstrong, not in any other number, or if you can convert the lambda value in nm, then you should remember hc has a constant value. Write it down, it will be very much helpful. 1240 eV dot nm. That's a unit. eV into nanometers. So when you will divide with a nanometer, when you will divide it with a wavelength, then you will only land up with eV. So now write it. 1240 upon 253.7. That's the eV. The answer that you guys are going to get is now going to be in eV, because eV nm, and over here it's also nm gets cancelled. Your answer, you are just getting energy. Now you guys have to let me know. 1200 divided by 250, 1240 divided by 253.7. You guys have to let me know the answer over here. What is the E value that you guys are getting? And now over here we have E, which is R, radiations. Work function is what you have to calculate. Kinetic energy is given to you as 0.24. 4.89 something. Okay, we'll go with the 4.8. Okay, we'll go with the 4.8. 4.8 minus, chalo bhaiya, 0.24. That is going to be your work function. The correct answer to this question comes out to be 4.65. 4.89. See, 9 minus 4, 5. 8 minus 2, 6. 4.65 is the work function. Amazing, right? Balle balle. Correct? Yes or no? Yes or no? It's good, yaar. You should remember these tricks, okay? You should remember these tricks. Is Abhi here in the chat? Oh, damn. I think he's going... Don't record my dance, okay? Okay, yes. Now, let's move ahead. Are you really enjoying the questions? Because I am really enjoying the questions with you. But the point over here is I am bringing up the whole chapter, the whole, all the concepts. So this is how I'm going to do. Every Sunday I'm going to be bringing up problem solving for you, or maybe I'll do it more, more frequently, but I want your enthusiasm, more and more enthusiasm. So ultimately, as soon as we'll complete the chapter, we'll do the question solving. And this is how we'll go, okay? And I am also going to be, bringing up ask your doubt sessions as well, where I'll be giving you, the Google form. You can ask your doubts from that particular chapter itself. You can write your name, you can write your place, from where are you talking, from where are you asking. I'll take your name, I'll take the name of the place. It will be really amazing. I'll keep it live, and I'll take all those doubts. Okay, so we'll do that. Okay, now let's move ahead. Which hydrogen-like species will have the same radius as that of Bohr orbit of hydrogen atom? Which hydrogen-like species? Matlab, there should be only electron, number of electrons, which is 1. Now, pay attention. Lithium 2 plus has 1 electron. Beryllium 3 plus has 1 electron. Helium plus has 1 electron and lithium plus has 1 electron. Correct. Sometimes they'll give you lithium plus. You have to neglect that option. So right now all the options looks legit. But now we have to dive into, but is there a trick? Yes, there is a trick. Now let's pay attention. So what is the formula that you guys are going to use? So ultimately we're talking about the radius. So Rn is equals to 52.9 into n square upon z. Is that the thing that we use? Z upon n is for the wave of velocity. Z square upon n square is for the energy. N square upon z is for the radius. Now Bohr orbit of hydrogen atom is A0, which is 52.9 picometers. Pay attention now. You have to really look for the options where n square upon z is 1. Then only you'll get the answer, which is 52.9. Correct? Now let's look for the z values. Z value over here is 2. Z value over here is 4. Z value over here is 3. Z value over here is 3. Now 3 square upon 3, is it 1? 2 square upon 2, is it 1? 2 square upon 4, is it 1? 2 square upon 3, is it 1? The correct answer to this question, that's the trick. Is it good? What you really have to look for is, you just want this value to be 1, because when we talk about hydrogen atom, it is 52.9 into n square, that is 1 square upon z value is also 1. We want this as 1. So whenever the question comes out to be that you have to actually calculate, you have to look for the options where the orbit, nth orbit is going to be equals to the Bohr's orbit. Then ultimately you just have to look for n square upon z value should be 1. Okay, I'm going to write it again. Look for n square upon z value to be 1. That's it. Okay? Best question in the class. Okay, I think there had been more, but okay. Okay, amazing, right? Now, in Bohr's series of lines of hydrogen spectrum, do you remember the lines? Lehman, Balmer, Paston, Pfund, bracket, all those. The third line from the red end corresponds. Red looks like visible region. The question is for the Balmer series, and Balmer series happens whenever the electron falls from any number of shell. This n could be any x, but it comes to n value 2. Correct? We'll talk about this. To which one of the following inner or by orbit jumps? Obviously from any of the orbits. The inner orbit jump means that it is not coming from the outside, it's actually jumping from inside only, from any of the other higher orbits to for the Bohr's orbit in the atom of hydrogen. So ultimately, just jumbling up words, but ultimately the question is, they've given you the hint, third line and the red. Now pay attention. What is first line? First line is going to be from n is equals to 3 to n is equals to 2. First line. N is equals to 4 till n is equals to 2. Second line. Third line is going to be n is equals to 5 till n is equals to 2. The question said third line. The question said visible region. Answer is from 5th till 2nd, and that is going to be the correct answer. Sir, how to face negative criticism? Even that's a good question. You know, sometimes there are a lot of students which come in my class and they will actually negatively criticize me. They might not be looking at my lectures and they might not be students as well. You know, some random people come and just say that. Just tell them one thing. Because even I am always ready for criticism. But if you are simply going to come and simply put your words, I really do not take. Okay? You know, you should not give a beep. Because you know why? Because ultimately you should remember, or maybe you can ask them, how do they really feel when their relatives, when any random person, you know, just negatively criticize them? Why do they do so, right? I mean, anyhow, for no reason or for a reason, relatives are always, you know, having a bad image. Like we all see the memes and all, है ना? So nobody likes it, negative criticism. And you know, when we have the power of internet, we should always try to encourage people. If I have to criticize you as well, I'll say no, you're wrong here, but you can do better, है ना? Or you know, if I am going to give you a negative criticism, it is going to be like, no, you're wrong and you're never gonna do that. That's negative criticism. So ultimately, you know, whenever you see negative criticism, if they're friendly to you, you can always ask them, do not do that, because it's of no use, because even you hate it. And if simply, you know, you cannot tell them that thing, ignore them. You know, there are a lot of dogs which bark unnecessarily at nights. It's okay, don't worry. Okay? Now, let's move ahead. Over here, the uncertainty in the position of an electron moving with a velocity 30 meters per second. Wow, velocity is given to you with an accuracy of 0.001%. So velocity is 300. What is delta V, boys and girls? This is percent. 0.001 into 100 is what you have to do. This is percent, right? No, percent. I mean, not. It should be percent upon 100. Correct? That's how it has to be. So this is 10 raised per minus 3. This is 10 raised per minus 2. So ultimately this comes out to be 10 raised per minus 5. What is going to be the delta V over here? 300 into 10 raised per minus 5. This is what you have to take as delta V. Okay. Now the uncertainty they're talking about, delta X dot delta V is equals to H upon 4 pi M is what you have to remember. But as we are looking for delta X value, what are you guys going to write? Delta X is equals to H upon 4 pi M delta V. This is the particular thing that you actually have to use, right? Yes. And now pay attention over here. Amazing. I really like the way you bring the chat to colors. Amazing, boys and girls. And now over here, pay attention. Delta X, you solve it with me as well. 6.626 into 10 raised per minus 34. What is the mass of electron? This is M, mass of electron. Nobody is going to give you the values. Okay, sometimes you have to remember. Let me know the mass of the electron in the chat. Oh, by the way, divided by 4, 3.14 into mass of electron, 9.1 into 10 raised power 31, 27, whatever. 1.9. Baapre. Got confused? 1.6 is the charge, right? 1.9 could not be the case. 9.1? Yes. 9.1 into 10 is for minus 31. Okay? Into, in the denominator itself, delta V. 300 into 10 raised power minus 5. That's how it is going to be. Typo mistake? Yes. It's okay. That's the reason I'm being, you know, I'm kidding to you. Okay, so now over here, solve. You guys have to solve. Come on, you guys have to solve. It's not me. Come on. So this is your time. Acha dekho, powers, anyhow, these things are going to get cancelled very much easily. It's minus 31, it's minus 34. And over here minus 5, and then do it again. It's 10 raised power 2 is over here. I'm not gonna do that. सर आपका अकाउंट हैक तो नहीं हो गया ना? I mean, why are you asking me that? सच में हैक हो गया क्या? Don't tell me. What happened? No, my account is fine. चलो ठीक है. Now give me an answer. The correct answer to this question. Khushi is giving me the answer, which is C. Yes, 1.93 into 10 raised to minus 2 is the correct answer. Khushi OP. Khushi is OP. Amazing. Khushi OP in the chat. सर आप क्लास ले रहे हो और रिप्लाई आ रहे हैं. Oh, you're talking about chemistry का लव? Yeah. So chemistry का लव वाला account is handled by not only just me but other people as well. ठीक है? So don't worry about it. Yes, I have given them the instruction. But anyhow, now let's move ahead. The uncertainty involved in the measurement of velocity of an electron within a distance of 0.1 Armstrong is. So guys, do let me know. Again, the question is from Heisenberg uncertainty principle. Over here, again, the formula that you guys have to use is delta x dot delta v is equals to h upon 4 pi m. Velocity of an electron, so mass of electron with the distance 0.1 Armstrong. 0.1 Armstrong is 10 raised power minus 1 into 10 raised power minus 10 meters. So 10 raised power minus 11 meters. That is the delta x value. Delta x is given to you. You have to look for the velocity. Delta v. H 6.626 into 10 raised power minus 34 upon 4 into 3.14 into 9.1, not 1.9, into 10 raised power minus 31. And delta x is also going to be here, 10 raised power minus 11. Amazing. Chalo. The correct answer to this question, it's absolutely going to be C, and Khushi has given me again. Khushi OP in the chat. And now let's move ahead. Oh yeah, we are absolutely at the end of this class. So ultimately, if you have any doubts, you can always ask us on Unacademy app. So do download the Unacademy app and follow me over there, where you can actually message me. But apart from this, you can actually ask unlimited doubts as well, boys and girls. And you should remember, you can ask these doubts anytime. And in return, you will get high quality video solutions in English as well as in Hindi. And you should remember that the question, whichever you're sending, should be clean, neat and readable. No handwritten material should be there, because it can become tough. You have to tell us which subject, after taking up a picture, you have to tell us which subject you're talking about, and try to put one particular question at a time. No 2 questions or 3 questions or multiple questions should be there in one screenshot. And then ultimately, apart from this, try to put all the options also available, and you'll get the solution always ready in front of you. Okay? And yes, all the do's and don'ts is what I have really told you. We are absolutely at the end of the session, and I am going to be bringing up more sessions like this for you guys. So stay tuned, subscribe to the channel, share it as much as possible, boys and girls, because we have to increase the number of members in this family, and only you can do it. I'm not the one who share it, okay, because I am the one who has to take the classes, and you are the ones who are going to share it. Make everybody subscribe, and yes, we'll meet again and again. Okay, amazing, right? Sir, ये वाला Q&A तो अच्छा हुआ. Yes, absolutely correct. And in the next one, we are going to bring up for the solid state. And you know what? There had been a lot of students who had been saying this to me. Sir, my school has started organic chemistry first in class 11th or even in class 12th. So you know what I'm doing for you guys? What I'm going to do for you? I am bringing up one-shot revisions of the organic chemistry chapters. We'll do it. It is going to be fun. Okay? So be prepared. Let's meet again. And these one-shot sessions probably what I'm planning is going to happen on this Monday and Friday. So Monday, Friday is how we are going to jump. Okay? Chalo. All the best, and guys, learn something from Khushi. Make your calculations a bit faster. The way Khushi does it. I mean, I'm just giving you an example. She had been doing it with a good amount of discipline and staying till the end. Take care. Bye-bye. Love you all. And again, a happy Teachers Day to you as well. because I even learn a lot of things from you. Bye bye.